And on to day 8 of our Exponents and Logarithms unit, and we're going to be looking at solving logarithmic equations today. So the first thing is we can see all sorts of different types of logarithmic equations, but using our log laws, what we want to do is try to manipulate the equation to fit one of the two situations that we see down below. So on the left-hand side, that situation is single logarithms with the same base on either side of the equation. And similar to what we've done with exponential equations, if we have two powers with the same base on either side, we can drop the base. With this, if we've got two logarithms with the same base on either side, we can drop the logarithms and then just solve the arguments or solve for x. And type 2 is, can we manipulate the equation such that we've got a logarithm on one side of the equation and, say, a constant term on the other side of the equation? And if we can do that, then what we're going to look to do is convert the log to an exponential and then solve for x that way. Now, one of the difficulties with exponents and logarithms is just the fact that there are often numerous ways to solve the exact same type of problem. And that's something that we looked at last day with 4 different strategies for solving the exact same equation. And it's not that there's one that's more right than the other. Perhaps you're just going to find something that you like and works for you, and you can use that. Yeah, so here we go. So we've got log base 5 of x plus log base 5 of x minus 3 is equal to log base 5 of 10. And actually, I should say we're going to bring non-permissible values and domain into this. So one of the things that I'm going to do is just jot the domain of each logarithm above. So log base 5 of x, we would say this is for values of x that are greater than 0. Okay, it would be impossible to produce an argument that was negative, so we say that x has to be greater than 0. And same thing with x minus 3, that's our argument. Our argument has to be positive, so we would say here that x has to be greater than 3. So when we get to our solutions for x, we want to look at the solutions in relation to the domain. Do our solutions fit into the permissible values of x? Okay, so let's use our log laws to turn this into a type 1 equation. So I'm going to use multiplication law on the left-hand side, so I can rewrite the sum of two logarithms as a single logarithm. And so this is going to become log base 5 of, and now my argument here is going to be the product of the two arguments. So x times x minus 3, and this is equal to log base 5 of 10. Okay, so from here we've got single logarithms with the same base on both sides of the equation. From here we can drop the logs and we're just evaluating the arguments. So we've got x times x minus 3 is equal to 10. Let's expand this. We've got x squared minus 3x. I'm going to move that 10 over. Minus 10 is equal to 0. And then let's factor this to solve. So we're going to get an x minus 5 times an x plus 2 is equal to 0. And so our solutions for x are 5 and negative 2. Okay, but I want to go back up here. Are either of these extraneous roots? Okay, well 5 seems to work for both logarithms, but negative 2 doesn't. Okay, if we were to plug negative 2 in for x, in both of those logarithms, we are going to end up with negative arguments, that's just impossible, so we're going to reject this solution. All right, moving on. Okay, I'm going to manipulate this equation to turn it into a type 2 equation. And I'm going to do that by taking that negative logarithm from the right-hand side of the equation, and I'm going to move it to the left-hand side of the equation in the first step. Okay, so writing this out, we get log base 8 of x minus 2, and then we're going to get plus log base 8 of x minus 4, and this is equal to 1. Okay, so one more step here before we have a true type 2 equation. I'll use multiplication law on the left to combine the sum of the two logarithms into a single logarithm. So we're going to get log base 8 of, and this becomes the product of the two arguments, so x minus 2 times x minus 4, and this is equal to 1. Now, from here, we are going to convert this to an exponential. So it's the base 8 raised to the power of the solution 1, 8 to the power of 1, we don't even need to write that, is equal to the argument, which is x minus 2 times x minus 4, and let's just expand that out here. So we've got x squared minus 6x plus 8. Okay, so we can solve this now. Those 8's are going to cancel each other out, so we're left with 0 is equal to x squared minus 6x. We will factor out a GCF of x on the right, so we're left with x minus 6. And our solutions for x here are 0 and 6. Now, one of the things that we want to do is just check the domain of each of those logarithms. So here, x has got to be greater than 2, and here x has got to be greater than 4. So going back to our solutions, 6 works, but 0 doesn't, so we're going to reject this solution. Okay, next one, so we've got 2 times the log of x. I'm going to use power law, and so I'm going to manipulate this equation to be a type 1 equation. I'm going to use power law here. The coefficient 2 is going to become x's exponent. So we get the log of x squared is equal to the log of 64, and these are both base 10 logarithms, so we can drop the logs from here, which leaves us with x squared is equal to 64, and so we're going to, if we were to take the square root of both sides, we need plus or minus the square root of 64, so our solutions for x are plus or minus 8. Okay, but the domain here, x has to be greater than 0, so we would reject the negative 8. I'll just write that in. Reject negative 8, so our solution would just be the positive 8. Okay, and one more here. So let's manipulate this equation to be a type 2 equation. And so our first step is we're going to divide both sides of the equation by 4. So we're going to get log base 3 of x is equal to 3. And so our strategy here is just to convert the log to an exponential. So the base 3 raised to the power of the solution 3 is equal to the argument x. And so our solution here is 27. Checking that against the domain, x has to be greater than 0, and we're all good. And that's it for today, just a quick one.